Well, good morning, everybody, and welcome to the first session from our series of webinars that we're going to be running today from Smart Vision Europe. My name's Jarlath Quinn. I'm an analytics consultant. I'm joined online this morning by my colleague, Rachel Clinton. Rachel will be making sure everybody's joining appropriately and be checking messages as we're going along. The first session we're going to be looking at today is IBM SPSS statistics. This is a topic that we return to on a regular basis because it's fairly popular with a lot of attendees. And we're going to be taking a dive into SPSS statistics and pointing out a lot of the sort of key functionality within there, particularly for people who are kind of curious about that, who have started using SPSS statistics or who are trying to assess whether or not it's right for them. Just a few FAQs that we try to cover at the start of these sessions. If you haven't joined them before, we do record the session, so you'll be able to listen to it afterwards. There's a little bit of slideware here. It's mostly demonstration, but we will email out a link to you so you can download a PDF copy of the slides afterwards. And if you think the session is particularly relevant for colleagues who are unable to join today, it may be possible for us to rerun the session on a private basis if we can get enough of them together. The best thing to do is just reach out and ask us, just send us an email and we'll see what we can do. Now, with regard to asking questions, generally speaking, we're pretty full up. So Rachel keeps an eye on questions while I'm demonstrating here and going through the session itself. All the lines are muted. We can't hear you. So we ask you to use the chat panel to enter your questions. We do generally get a bunch of questions at the end of the session, and we usually just follow up with them on an email basis afterwards. So if you just make sure you let us know your email or something like that, we'll email you afterwards and give you perhaps a longer answer or a more thorough answer to any questions that you might have. But either way, if you ask a question, we will do our best to answer it at the time or after the session's ended. If you don't know who we are Smart Vision Europe, and we're a fairly long established small company that specialize in AI, statistics, machine learning, that type of stuff. We're a gold accredited partner to IBM. And we're also a partner to Predictive Solutions and to a company called Data Robot, looking at analytics and big data technologies. But we also work with open source technologies such as R and Python and Spark, and we're made up of a team of people. We all have about 15 to 30 years of experience working in the advanced and predictive analytics industry, the common denominator being usually that we've all worked for an extensive period of time for SPSS Incorporated. So I worked for SPSS for many years, from 1995 before joining IBM and then joining SAS Institute afterwards as a senior consultant. So this is an area that we have a lot of experience in. A lot of experience of teaching SPSS and providing technical support around it and applying it in a range of different analytical applications across many different sectors. As you can see, there are listed things like retail and gaming and power utilities, water utilities, telecommunications such as infrastructure and telco companies, mobile phone companies, as well as things like broadcasters and media. And even things like manufacturing, fast-moving consumer goods. So a huge range of applications where we've used this type of analytical technology down through 3 decades worth of experience. So today we're going to talk you through SPSS statistics. We're going to give you an overview of the package first of all. And then we're going to start with trying to get data into it and looking at how we get data into the system itself from things like databases and spreadsheets. We're also going to look at very, very important in SPSS, a real key aspect of it is it really wants the data to be formatted in a particular way. This is one of the things that people who are new to the system struggle with, is it maybe behaves in a non-intuitive way, or it doesn't do what they want them to do. It doesn't give the results that they're expecting to see because the data hasn't been formatted appropriately to SPSS's liking. So knowing how to format the data is really important. And then we'll look at playing around with the data, such as creating filters in the data set or creating new versions of an existing field, such as creating something like age group from age. And we'll also look at one of the modules, which is the custom tables module, how that allows us to create quite complex tabulation, as well as things like finding statistically significant differences in groups and anything else that occurs to us at the same time, such as charts or graphics. Okay, so let's start with an overview of SPSS statistics. So it's actually but possibly one of the world's, if not the world's oldest professional software application, because it's been around since 1968, which is pretty old in computer terms, in software terms. Indeed, it predates the software industry by quite a few years. It's used for everything. It's a bit like Excel. There isn't really a typical user of Excel these days. They're not accountants anymore. People use Excel for all sorts of stuff, and people use SPSS for all sorts of stuff, whether it be epidemiology or market research or academic work or business reporting or direct marketing, credit risk or whatever they want, asset management. And as we'll see, there's a basic software package called the base. And things that you would get in that are things like, crosstabs, frequencies, descriptive statistics, as well as lots of statistical, bivariate statistical tests like t-tests and correlation, multivariate stuff like ANOVAs and linear regression, and things like factor analysis and cluster analysis, as well as all the charts that one would expect and all the data manipulation capabilities one would expect. But the fact is that SPSS for many years has been sold as a modular system, so there's lots of these different add-on modules. These days, IBM tends to make that simpler just by bundling them together into different themes. So you'll have like SPSS Base, SPSS Professional, SPSS Advanced. So you get a group of these modules that come with them, and they all perform very specific specialist analytical tasks. If you were interested in the difference between them, I'll show you a link to that. But to give an example of one of these, if we take one of them, like the decision trees module we see down here, where's that decision trees? There it goes down there. I mean, how would that appear? Well, it's just an additional menu item that appears in SPSS. It's unlocked by a license code, and decision trees is very popular because it's used to, for example, build predictive models, to create profiles of customers, employees or clients or students or whoever it is your target group that you're analyzing. And it finds key behavioral segments within the data very visually. And because it's visual, it's very popular, and the models are relatively easy to understand compared to the sort of statistical models that you get from a lot of statistical packages like SPSS, where pump out lots of coefficients and technical values to you. This is an example of a decision tree. This is survival on the Titanic. So you can see 67.7% did not survive, 32.3% survive. And what the decision tree does is it tries to find the key discriminators hierarchically, what are the most important factors between survival and non-survival. And what you find is that from the thing that drives it, of course, is gender and people's sex, whether or not they're male or female. 73% of females survived, only 21% of males survived. And for males, it then splits this group of 1,731 passengers, male passengers, into another two groups. It picks 64 children, male children, and 1,667 adults. You can see the relative change in the survival rate. And then for male adults, it splits it into first class, second class, third class, and crew, because that's the next most important factor. And you can see that actually the people with the lowest survival chance are actually people traveling in second class who are male adults. Male adults, second class, 8.3%, compared to third class, 16%. So nearly half as likely to survive. So it's really good at finding these sorts of exceptions to the rule. It's very good at finding these segments within a data set that are really interesting because it's only putting in variables which are statistically significant. You can see here for the female branch, it doesn't use the variable age because it's not significant. It doesn't make a difference. And you can also see for the female branch, it actually groups together second class and crew because their survival rates are so similar that it makes no difference to the significance value, or doesn't make it less significant. So it's finding the most efficient versions of variables. It's be an example of a module that you would run in the SPSS. And of course, one of the reasons why it's popular is because you can apply it to so many different things, whether it be things like survival or whether it be things like people responding to an offer. In fact, you would say that this is kind of a gentle introduction to machine learning and how predictive models are applied and how AI systems are kind of founded. They use things like decision trees, a lot of them, very similar techniques to build up a series of rules. So there's IBM SPSS decision trees as an example of a module. If you want to look at the other modules there, we have, as I say, a little video guide that would probably about 2 minutes, 2 to 3 minutes video overview of all of these different modules. If you want to know what the data preparation module is, I should say that these days IBM has started to put some of these old modules, started to bundle them into the base system. So things like bootstrapping is now part of the base. Data preparation is now part of the base system. So some of them are still very part of the core, and some of them are part of the optional add-ons that people can choose if they don't have access to that particular functionality. Okay, when we teach people how to use SPSS, and when we deal with people who work with software like SPSS, whether it be R or SAS or whether it be Python or something like that, we're very aware through years and years of working in this area that the things you're looking for in your analyst or in your consultant or in your data scientist is they've got to be able to just demonstrate skill in at least 3 areas, and one of those is a need to be able to be good at getting data into the system, and that's a universal problem because data comes in all sorts of shapes and sizes. It can be in text files, it can be in native files like Excel, or it could be in databases or data lakes, or it could be online. And being able to import and format that data correctly for the target system is kind of a key capability. And having done that, you want to, generally speaking, clean up the data, for example, and make the best of it. So that's going to involve things like stripping out extreme values potentially, or removing, selecting the subsets of the groups that you really want to analyze, and maybe creating new fields like age from date of birth, or income category from income, or the ratio of one field to another by maybe creating some conditional rule. And then finally, you need to be good at analysis. You need to know, this is the right sort of analysis to do with these 2 types of fields or these 3 types of fields. And this is how I'm going to present it, and this is how I'm going to deploy it. So we would boil that down to 3 key areas where people who are good at SPSS statistics or other types of packages can demonstrate skill in. And those are the 3 areas that we're going to take a look at when we look at SPSS statistics now. So let's just skip out to SPSS statistics. This is what it looks like. If people think, if it looks a bit like Excel, that's kind of understandable, but it doesn't really help too much, because it's not like an Excel package at all. It's not like Microsoft Excel. It's completely different. I'm just going to move the taskbar out of the way here so I can see it. If we go to, for example, the help system here, I'm using version 29, and go to topics. It'll just load up, obviously, a help page on the web here. And we'll just give it a second, because there's one thing I wanted to draw people's eye towards, which is that, there version 29 means there's a lot of different versions of SPSS out there. And people always want to know the difference between one version and the next. This is taking a long time to actually load. Let me try it again. See if it's actually just that particular session. It's causing problems. It does seem to be just that session. If I go to, when you land on this page, if you click on overview, what you'll see is what's new in version 29 and 29.01, what's new in version 28 and 28.01, what's new in version 27. So if for whatever reason, if you're in version 26 and somebody else in version 28 and you want to know what the differences are between them, this is where you come to find that out, just within SPSS itself. And generally speaking, the differences between one version and not are very, very subtle these days. You know, I mean, there's a lot of continuity. You're not going to find that you can't read a file from version 14 into version 29. The file structures are pretty much the same from one version to the next. They're pretty subtle. It's hard to glance at a copy of SPSS and think and know exactly which version it is you're dealing with within that copy. So we have this sort of spreadsheet-like window, which isn't a spreadsheet. It's actually called a data editor window. And SPSS has multiple data editors, or sorry, has multiple windows. You can actually have more than one data file open at a time. You need to have more than one views of this. You can see here under window, I've just got, it says untitled dataset. So we've just got one window open. As I start to open data files and do stuff to the analysis, it starts to often open other windows. So it starts to create things like an output window where I can see the results of the analysis I'm working on. So one of the first things I'm going to do is just try and read some data in. We said we'd start with showing how to read data from databases and spreadsheets. So let's pick a database here. If I go to the file menu, as you'd expect, that's where you read data in, pretty universal in Windows. I go to file, open data. That's going to open a little dialog box here, and it's going to look for SPSS file types called SAV files or save files. If I want to import data from an external system, I might go to import data, import, and database new query. If I click on that, that opens the database wizard here for me. And the database wizard is a way for me to connect to multiple databases at the same time. So you can see here, if I wanted to, let's say I've got something like a DB2 database or an Oracle database somewhere in my system and I want to connect to it. Well, what you normally do is you click on this button here. That calls, in this case, it calls Windows. And that allows me to define a connection to Windows. So I've got a SQL database here called main. And I've got a couple of little employee access databases. That means an MS access database, just a Microsoft access database. So let's have a look at that. Let's click on, let's say somebody sent me an access database and I want to connect to that. Well, I'll just click on that and hit next. And you see it says, okay, where is this database? We're going to browse for it, of course. It's in my webinar session here called Getting Started with SPSS Statistics. Ironically, it's looking for an Excel file because that can be used to also read in Excel files. And here's my first one here, employee data.mdb. Click OK. And you can see here, in this case, it's only got one table. You might have multiple tables, so I could drag them across here and it would automatically connect them together for me using a common ID field, which is how relational databases are connected together. Hit next. It takes me down through this database wizard where I can type in an expression here. This is really non-native SPSS. It's like a SQL expression or something like that. If I wanted to put in a SQL expression here, say, only select people who have become customers, let's say, since January 2023 and who are, in this particular region 2 or something like that. In this case, I'll just read them all. It shows me what the fields are going to be called, or the variables, as stats packages call them. We hit next. It shows me what the SQL looks like, the SQL query looks like, because we're talking to a database. I could alternatively turn that into what's called SPSS syntax, which is SPSS's old language. Obviously, if it was written in 1968, it has to predate Windows. Windows didn't exist. You had to type in commands. Those commands are still available as SPSS syntax. They're very useful. We run sessions and we have recordings of how to learn how to use that. If I hit finish at this point, it goes and reads the data in. And the first thing we notice is that the data is very raw. Okay, so it's just a series of numbers and values really that are just they're just sort of sitting there within the spreadsheet. And if I can kind of play around with it, I can edit them. So for example, I can take gender here. Gender's only come in with a width of 1 because that's how it appears within the database, given a width of 1. But if I just display it out here, you can see it's M and F, so we can kind of guess what those values refer to. I can take a value like age here. This is obviously numbers, and a value like educ here, education. I can probably guess what these fields relate to. But This is one of the things we're talking about when we talk about formatting the data. So SPSS is very sensitive to formatting. If I right click, for example, on this and hit descriptive statistics, this is one of the first analyses I can do. It will open up a new window for me. This is called an output window, and it shows me a little frequency table here. It says you got 216 females and 258 males. Okay, so but I might want to change this so it actually says female rather than F and M, F and M, female and male, and maybe I have this as employee's gender or sex of employee rather than just gender. So that's about formatting. It turns out you have this view of the data, which is shown down here in the variable view, where you have all these properties you can attach, metadata properties you can attach to it. So for example, if I type in the variable label, sex of employee, I can also attach what are called value labels. So I can say, this is a critical thing here, F for female and M for male. And one of the reasons why it's set up this way is because historically people would type in the values directly into the computer themselves. They didn't have online surveys or anything like that. They type in the data directly into the computer themselves, and they'd use codes. You wouldn't type in the word male and female because obviously you might misspell it or something like that. You do it uppercase or lowercase. So you just type in the codes F and M. And now when I run the analysis, it just looks a little bit neater. It says sex of employee and it says female and male. So that's one of the first ways in which we can format the data. There's another thing here. If I right click on this field here where it says salary, hit descriptive statistics, you can see that it doesn't give me a frequency table. It gives me some summary stats. So it's very sensitive to whether it's a number field or a category field. Here it's showing, I'm jumping on into the output here. It's saying the mean salary is 33,941. And the median salary, that's the halfway point, the 50th percentile, is lower at 28,500. That's quite common. That probably means we've got some quite high salary values there, which are inflating the mean. But what's important here is one of the first things to do is I notice that the minimum value is -1 and the maximum value is 135,000. I think this was from the 1980s. It's a bank that was used that collected data in the 1980s about its employees. It was actually a very famous data set because it was used in a court case in Chicago in 1980s for an equal opportunities court case. And they used the statistics from the bank to prove that there was discrimination in how the salaries were being paid. And that's why it pays attention to variables like whether or not people are an ethnic minority, how much previous experience they had in months, how long they had been in the job in months, what their starting salary was, what the current salary was, what their job category was, how many years of education they had, and what age they were, etc., and whether or not they're male or female, because these are all demographic pieces of information where they were used to compare and contrast similar groups to one another, and look at the differences in salary. But one of the things I notice here is that because it's got all these -1s, if I just sort this in ascending order, what are these -1s? Well, these -1s just refer to missing values. That's a very important aspect of SPSS, and it's another property that we can change. So if I double click here, I can go to missing here and say, okay, look, I'm going to give you a missing value, and that missing value is -1. I'm going to tell you that the missing value is -1. And that means that won't be included in the calculation of any statistics because it's effectively unknown. We shouldn't be calculating an average where people's salaries is -1. It doesn't know at this stage until I tell it that's a non-legitimate value. If I run descriptive statistics again, now you can see that the median has changed here from 32,941 to 34,450. So it has affected the mean value. And now the minimum salary is $15,750. So this business of formatting the data is very important. If I wanted to go through this, I could click on this and say, job cat means this, and gender means that, and code 0 for minority means they're not an ethnic minority, and code 1 means they are an ethnic minority, etc., etc. It turns out if you've done this already in the past, and you're always reading in raw data, you can just use a previous file as a kind of template. So let me just show you an example of a file I've already created here, where I've already formatted it nicely. I'm just going to show you this file. First of all, let's go to getting started with SPSS statistics again. I've got a file here called employee just the variables.sav, so it's an SPSS file. And we'll just say, no, we don't want to save that. And you can see it's just got fields in it. It hasn't got even any data in it. I mean, it doesn't matter if it has data in it. I just wanted to emphasize the fact that the data is not important. And you can see everything's been formatted here. So let's read in another file. This time I'm going to read in an Excel file. I'm going to go to import data Excel. There's employee workbook.xls. It's a different type of file from an access file, but it's as a result of that, it's got a different dialog box. Here it is. It's saying employee workbook's what I'm going to try to read. Here's a little preview of what the file looks like. It looks pretty good. I can tell it to ignore hidden rows and columns. I can tell it if there's any hidden spaces after the string characters like M and F. I can tell it remove any trailing spaces and remove any leading spaces. I find that's a pretty good idea to switch that on. And this business of the percentage values that determine data type, well, it's trying to guess whether or not this is a category field or whether it's a number field. If 95% of the values are just numbers, it's probably going to assume it's just a number field. But if I switch that off and 5% of the values or some of the values, maybe just a tiny minority of them, actually have letters in them, like X for unknown or something like that, then it will read those and it will read it as it'll read that field as a character string. So this is basically saying what percentage of the values do you want me to pay attention to try and guess what type of field it is. So we'll leave it on. Click OK. I think we're all right in this one stage. Reads it. It looks very similar to before. This time, if I right click on salary and look at descriptive statistics, you can see minimum salary is 15,000. This particular version of the file doesn't have any of the -1s in it that I had beforehand. It still has it actually has some decimal places here for job cat. That's not important. But I can take my earlier file that just had the variables in it, and I can say I want to copy across all the information that should go in here to this point from this earlier file. So I can say copy data properties, look for this file where it says employee just the variables, click OK, and hit next, and it matches them by field name. And here are all the properties that it's going to copy across. I can say I want to replace them or merge them with existing properties. So things like value labels and missing values and whether or not it's a number field or a category field and that kind of stuff. Hit next, and it clicks finish at that point, and it suddenly just formats all the data for me. Okay. The only thing it hasn't done is, and for deliberately, it hasn't pulled across the formatting for gender. So if I wanted to show you how to do it, you can see this is string. This time, because it's a string field, sex of employee, we're going to do that manually. We just need to give it, instead of letter codes, we need to give it instead of number codes, we're going to give it letter codes, so character codes. So we go M for male, F for female. Maybe so it doesn't have to perfectly match. It might have, it might not have the field gender in the file that you're copying across stuff from. So the reason why that exists is simply so that you don't always have to manually set up all the value labels and all this information here and attach all of these different values to it, etc., etc. You can actually just save your data file away and use it as a sort of template going forward so that you can format your data. So if you're thinking about where we are, we're at the stage where we know that we need to read and format the data correctly, which means we can now look at transforming and manipulating the data. So we've looked at how we can read data in and how we can format it and why formatting makes a difference. If I right click, for example, on this field here and ask for descriptive statistics, it gives me a nice little table here telling me employment category, what proportion of people were clerical workers, what percentage of people, the valid percent, are custodial, and what percentage were managers at 17.7%. And it does that correctly because it knows how to treat that field. That field has been set up as a category field. This little symbol up here indicates it's actually an ordinal category field. Whereas if I look at eddoc here and I right click on that, it doesn't try to give me percentages. It gives me the summary statistics here. So it says the mean is 13.49 and the median number of years of education that employees had was 12. The minimum was 8 and the maximum was 21. Okay. So at this stage, we can say, well, this is really useful. If I wanted to look at salary or beginning salary, that type of stuff, and I want to look at it as percentage, as just as summary statistics, that's fantastic. But what if I wanted it as percentages? Well, you can't really do much with percentages. I mean, if I force it to give me a percentage of salary, of course, it's going to look crazy because there's too many individual salary points. If I click OK on that, it just gives me a table that looks like this and tells me what percentage of people were in 47,250. There's 0.2%. So ideally, what we want is if I just delete some of this output, I can actually delete all of the output and start blank and go back to the data. Ideally, what we want is we want to be able to have two versions of this field. We want to be able to have the salary and the salary band. And then we can look at both, things like histograms, which is a way to summarize continuous data, and bar charts, which is a way to summarize category data on the same field. And the way in which I would do that is I go to transform and I'd go down to visual binning. And if I pick on current salary here, I continue, what it does is it shows me a histogram. So it's actually showing me a representation of this distribution of salary values here. Each bin is just a little automatic grouping for the salary. So I can say, okay, look, I want to create a new field called sal band. You can see here it's going to call the label current salary binned. I'm going to change bin to grouped. Okay. And then the really clever bit is when I go to make cut points, it says, well, okay, where do you want to slice this cake, if you like? How many bits do you want in it? So what I tend to do is I tend to go for this middle option and say, I want even slices. I want the same amount of cake in each slice. So I'll say I want 3 cut points. That means a width of 25%, and hit apply. And it finds the values where you slice the distribution, if you like, that will try to, when I say try to get you 25% of the data. Sometimes it just can't do that because, there aren't, the data doesn't distribute itself that neatly that you can get 25% out. But these are the values here, and we can see that some of them are very specific. So for example, here it says 37,050. That's probably a bit of a weird place to slice it. So maybe I'll just change that to 37,000. I can alter that value if I click edit that. What actually happened was that slice point just moved a tiny amount. If I pick here 28,875, I can actually move that just manually. And it just updates at 29,000. So let's just change it manually here to 29,000. And that moves at that point. So now we've got 24, 29, 37, and high. And now we can say, okay, this is going to create groups 1, 2, 3, and 4. Let's make some labels for that. And it makes some labels for me. These are in dollars. So I'm going to just change this less than the equal sign here to make it more readable and say, up to $24,000. And this one here, 37,000 plus, I'm going to just say, change this to over $37,000. And then once I'm happy with that, and I've changed the labels, and I like the labels the way they are, then I'll just click OK at that point. It says I'm going to create one field for you. And now we've got another version of this field, but it's just been grouped together for me into bands. So it's very easy. And if I right click on that and do descriptive statistics, it shows me percent. You can see it's not exactly 25%, but it's close to 25%. So now I've got two versions of this field here. I've got one where I can take summary statistics on it, and one where I've got categories. Now, why is that useful? Well, obviously, summarizing the data, there's lots of ways in which we can summarize data. We can do bar charts, we can do averages, we can do medians. But very often what we want to look at is the relationship between one field and another. So, for example, here, if I went to analyze perhaps the most commonly used procedure, which takes its name from the SPSS code word or the keyword and syntax for the procedure, is crosstabs. So crosstabs owes its name to the SPSS command crosstabs, which is short for cross tabulation or contingency table. And that means I can look at the relationship here, say between employment category and current salary. So one in a crosstab, one field goes into the row and one field goes into the column. It doesn't really matter which one goes where. You can ask here for clustered bar charts, and you can ask it to add into the crosstab rather than just the frequencies. If I click OK at this point, you can see it's just going to give me the frequency numbers. So you can see that, for example, managers, nobody's on up to 24,000, nobody's on 24,000, 29,000. One of them is on 29 to 37, and they're all 83 of them are on over 37,000. So there's quite a big difference here. You can see this is obviously reflected in our bar chart here. So there's a massive difference. And of course, if we could add in sales, we could say, show me the row percentages of that. Actually, column percentages would show me what percentage of the employment category each group belonged to. Click OK at that point. Now we have percentages added in. So it's saying, 33% off clerical workers and up to 24,000, 32%, 24 to 29, and 25%, 29 to 37, only 9% over 37. Nobody in custodial work is over 37. Nearly all of them are in the 29 to 37,000 group, and 98% of managers, of course, as we know, is over 37,000. And the lovely thing about this is what makes it powerful is just the way in which I can now start to play around it. Now you're kind of off to the races, and you can say, okay, let's look at sex of employee by that. We'll look at that. Oh, look at that. Now there's a difference here. Look at the males. Not very many males under 24,000, about the same number, 24, 29,000. Then as you get into the higher brackets here, see it starts to get higher. Do the same thing here, looking at minority classification. Click OK at that point. Here's minority class. So you can see that there aren't very many people in minority groups. So it starts to get harder to compare them. This is why percentages is so important, because we can say off the minority group, 28% of the people who were an ethnic minority in the bank were on up to 24,000, 38%, 24 to 29,000, 25%, 29 to 37,000, only 7.7% over 37,000 compared to those in the non-minority group, over 30%, over $37,000 in earnings. And the other thing that's really powerful about crosstabs is the way in which we can play around with it. So, for example, I can actually put this into what's called the layer box and then look at gender and then say, well, look, is this relationship between current salary and sex of employee, is this the same for people in minorities and people in non-minorities? It becomes a sort of control variable, and it means it produces two tables for me. Now, in fact, tables in SPSS output are pivotable. There's a lot going on in here. There's a lot of information. So that means you can double-click on them. You can call up pivot trays, and you can pick something like minority classification and put that into what's called a little pivot layer dimension here. Let me just show this. So there's the non-minority. These are all the white people. So 46% of the females on up to 24,000, 4% of the males. 49% of the males, white males, on over 37,000 compared to 9% of the females. Let's look at the minority group here. 0% of the females in ethnic minority groups on over 37,000 compared to 12% of the males. 37% of the males in ethnic minority groups on the 29 to 37% scale here. And basically, there's some interesting relationships going on here among these three different groups. This job category groups is what you have is the clerical workers, and it was the clerical workers that brought the case against the bank. 364 of them, and they were really looking at the disparity in payment terms for clerical workers between ethnic minority and non-minority groups. The custodial workers there's only 27 of them, but they tend to be obviously things like people at facilities, caretaker, security, that type of stuff. And most of them are much older, and a lot of them are in ethnic minority groups. So they're kind of a very specific type of group in and of themselves. So there is a story behind this data set, and it's a nice data set to play around with. What else can we do here? Well, the other thing we could do is we could say, well, look, let's just filter out, if you like, the custodial group. So we're just looking at them. Well, one of the way in which I do that is given that the case, the court case was kind of interested in just the difference between clerical workers versus managers and the differences there. I could say, okay, I want to select if the employment category is not equal to, that's not equal to, if I right click on here, what is the code for custodial workers 2? The fact that within every dialog box, you can resize the dialog box. One of the really useful things is you can right click and just see the codes. So if you ever have to point to the codes, it's group 2. You never point to the label. Say, if it's not equal to group 2, click continue, click OK. It filters that group for me. That's called a filter on. And if I now look at descriptive statistics, you can see there's only 2 groups that show up, clerical and manager. Another way to do this is you could go to select cases and you could say, okay, just create a new data set for me and say, no custodial. Call that you create a new data set for you, called no custodial. Click OK. And it opens up another little data set here. You can see it's got the label no custodial. So it allows you then to work exclusively on them. And then you might want to say, okay, I want to compare the mean salaries. Let's compare the mean salaries for people who are in clerical and managers groups against ethnic minorities. So I might say, okay, let's look at compare means and means here. I say, what I'm looking at is beginning salary. And I'm going to be looking at employment category here. And I can even break that down into subgroup and say, okay, I want to look at that by minority classification here. Now I'm breaking the subgroup, and it's giving me this little table that's coming out here of means. So we can say, look, there's the clerical and the manager group for non-ethnic minorities and ethnic minorities. So we can see that for ethnic minorities, they're earning less than the non-ethnic minorities, and in the management group, they're actually earning slightly more. There's only 4 of them than the non-ethnic minority group. So it's kind of an interesting little pattern going on here. You might want to explore it further. Okay, now our tables are starting to get kind of busy, and I want to go back to this group here and this data set here, my original data set. So I'm gonna shut this one down just by saying no. Don't keep the data set no custodial. Just go back to the old one. Make sure the filter is switched off here. Go and select cases and say select all the cases. Now my filter switched off. I'm going to actually delete some of this output here for me, and I'm going to look at other ways in which I can look at the relationship between these groups. So I'm going to say, okay, let's look at a module here like custom tables. And what I want to do is, rather than look at percentages exclusively or means exclusively unknown, what I want to do is actually build up a little custom table report here. And this gives me a very visual interface. So I can look at employment category here by salary across the top if I wanted. And I could have gender as a subgroup of that. So you put that in there. And I could remove the label gender, because obviously sex employee is not that important. And then I might put something on the end here. I might say, look, I'm really interested in things like people's average years of education. So I might put mean years of education on the end here. I might look at what's the mean number of months that they've been in the job and what their previous experiences on average. And now I'm getting a much bigger table growing out. And I might say, okay, categories and totals here. I'm not actually interested in the custodial workers, so I'll get rid of them. Click OK. I want a total here. I want to change the value total so it says base rather than total. So I've got a lot of control over here, and I want it to appear at the top. And now base appears at the top. And now I might say, okay, well, actually, I don't want the frequency counts in there. I want to change that. So I've actually got row percents rather than frequency counts, or at least row percents on its own. So I'll change that label there to percent. So I've got a lot of control here. and click apply the selection, click OK. And it runs that, and you can see this table starts to come out at this stage. I could actually double click on this piece of output and highlight some values in here and say, okay, let's look at clerical workers versus manager workers on previous experience in months and education level. Let's just look at that one there and say, okay, let's right click on that and say, create a chart for me. And it goes and creates a little bar chart for me. Tells me, well, so you can graph little bits of it. It's quite useful in that sense. So a tables module helps us create much more complicated tables. But what if we want to do like just a standard statistical test here? If we want to do a standard statistical test, let's just look at, say, the relationship between job category and gender. Let's say we just want to look at the relationship between that. So if we want to do a standard statistical test, we might do something like a crosstabs here. Let's hit reset to clear out the dialogue and start from scratch. So we're saying I'm going to put gender in the rows, and I'm going to put employment category in the columns. And I'm going to compare. This is just for aesthetic purposes. It doesn't affect the statistical test itself, but I want to show the row percentages in there. And I want a test. It's just a statistical test. The test you would normally use with that is chi-square. This is the same test that is used. The chi-square test is the same test that's actually used here in this decision tree. See the chi-square? That's what's identifying what makes a significant difference to the tree. What is a significant discriminator between people who survived and people who didn't. So it's actually the same test. We can run this again. Let's go back here to the and click OK at that point. It gives me the table that we saw earlier on. So we've got 95% of female workers or female employees or clerical workers compared to only 60% of males. Is this sort of statistically significant? Well, the value here is 0.00, less than 0.001. And what you're actually doing is you're testing the null hypothesis that how often would you see a result as extreme as that in a universe where the men and men, there was no difference between gender and people's employment category. And it's saying, well, in a universe where there's no difference between people's gender and their employment category in this bank, you'd only see a result as extreme as that, as the difference that we are observing, less than 0.1% of the time. So it's a very, very small value. In fact, it's just summarizing here. It's actually a really, really tiny value. You could actually show it's 18 decimal places. It's 4.9. It's 49736, but 18 decimal places back from that point. So it's like 0.00000. It's a lot less than 0.1%. It's saying a result as extreme as that is, if it was happening randomly, if you like, is extremely rare, and you wouldn't see it. So you would basically say this is, I hate the term statistically significant, but you'd say this is a statistically significant result, and you would reject the null hypothesis that there's a significant difference between so there's no relationship between gender and employment category. By the way, the threshold value that most people choose is 0.05. If that value is less than 0.05, to less than 5%, a mere 5%, that's the point at which they say things are statistically significant, and that you reject the null hypothesis. You may be aware of that already. Okay, so we've kind of walked through a lot of the stuff that we were talking about earlier on. I just wanted to point out a few extra little things here. One of the things is that you've got a nice chart builder here. And I think the chart builder is particularly good in this data set because it allows me to look at the relationship between things like salary and beginning salary. So if I say, okay, I want to do like a scatter plot here and do salary and beginning salary. And I can color it by, again, obviously things like employment category. If I wanted to, I could actually put in another variable at this stage and do, and have one. Let's have the size affected by something. If I click OK, let's have the size affected by previous experience, something like that. Click OK. Now we've got nice little chart that's come out here. It's a nice little sort of bubble plot. The size of the circles relates to how much experience they've got. And and the colors relate to where they are, whether or not they're clerical or custodial workers. We can see there's a strong relationship here between beginning salary and current salary. Here's all the managers. It does start to funnel a bit. You're starting to see a bigger difference between beginning salary and current salary, but still a very strong relationship between, you can predict somebody's current salary from their beginning salary. But there doesn't, it's not like you know, the higher the salary, the larger the circles are getting. So we're not really, there's no real evidence looking at this chart that your experience really increases your current salary particularly. It's not like the values up here have larger circles. If anything, current salary seems to be more associated with people with less previous experience than more previous experience, and that could be affected by the fact that the custodial workers, who are this red group, they have very large circles. They have a lot of previous experience. They tend to be older than one another. There are other things we could do here. For example, we could create a variable like age from date of birth here. It's got a lovely procedure called date and time wizard. I'll just show it to you very quickly. I think it's a really good procedure for working with date fields. I've got date of birth here. If I wanted to calculate the length of time between two values, I could calculate with dates and time. So I could say, okay, let's calculate the number of time units between two dates. And I can say, let's take the current date, date of birth, and hit next at that point. And what's that going to show? Well, that's going to show their age today if they were still alive. I don't need to give it a label. And click finish at that point. There's age today. That's what age they would be today. They're still alive. Well, this data set's probably about, I don't know, 30, 35 years old, something like that. So I guess if I wanted to figure out what age they were then, I would take 35 away from that. So I'd go here to transform and go to compute, and I'd create a new field. This is like a little calculation procedure. I'll call it age then. I'll just take age today and minus 35 off that and click OK. And then we have age then, and it's got decimal places in it. But again, you see, I can format it. If I want to click on the formatting with that, I just double click on it. They get rid of the formatting, change the label to age of employee, or estimated age of employee. And there we have it. We right click on it and do descriptive statistics, and it says, okay, look, it's the minimum age is 17, the maximum age was 59. I've probably overshot it a little bit. Probably the minimum age was 18, I would think, probably something like that, or 19. But you get the idea that we can do that sort of calculations. And then, of course, you know, we could add that into our scatter plots. The last thing I wanted to point out really was the fact that everything we do is kind of recorded by SPSS. So if I look at this cross tab here, I hit paste, it actually shows me the syntax that you're running there. So that means that I can record my analysis. I can run that again. See, it produces that again, and I could go back and say, "Oh, let's look at that chart builder you did there. Let's hit paste on that." It's now just added that syntax to the output. There's a syntax of the chart builder, quite busy. If I go back and say, okay, what about the means procedure we ran earlier on? I think I've reset that, but let's just say I was doing it again. Let's look at employee education and salary, and we'll break that down by employee category and have it nested by whether or not they're a minority. Hit paste on that. Eventually, I can just build a little report and highlight it and run the whole thing, and it'll just go and create all that output for me automatically. So in that spirit, if I just close that down, if I then just close this syntax window down, which is opened up, and I close this down, this data set down, so I've got nothing open now. It should just be empty window. Yeah, that's the only thing that's open. If I go to file, open syntax, let's just see if I can find this. Let's see, demos, smart vision, webinars, seminars and webinars. Getting started, SPSS statistics. There's sample syntax there. I've got, click open at that point. And you can see what it does is it actually starts getting my little data set in from my access data set, the first thing I showed you. Then it applies the formatting to it using that file that we had earlier on called employee just the variables. And then it does some recoding. It creates age band as we did around. Then it does crosstabs and descriptives and tables and charts and more charts in one go. So you could, if you're reading the same data on a regular basis, let's say on a monthly report or something like that, then it's very easy to kind of within SPSS to just sort of automate your all of your analysis. So you can click start from scratch and say, get me the latest data, and go and run your analysis on that and produce a report for me. And look at the output, and the output then is just generated for you. If I just go, hold on here to sample syntax, what's that something? Active data set is employed. Let's see if I run this. I run all of this. Has that all been formatted for me? It's mostly been formatted for me. Syntax, if I just highlight run all, sorry, there it was. It was running in the background. So I can see the output that's been created here. I'm just trying to move my this Zoom taskbar out of the way. And there it is. It's created all this output for us. Create this table, create a little report. Here's a scatter plot. Here's a histogram. Here's more tables and charts for us. And it's done all of our analysis automatically for us. Okay, so that's our little tour through SPSS statistics. A couple of additional resources that you might want to bear in mind is that we have some FAQs that you link to from this PDF you're going to get, which is everything from finding out what you have installed to how to merge files, to change the language. A lot of video guides, a lot of how-to video guides with lots of little mini demos, information in the SPSS software, and a blog series on basics inferential statistics called Eat Your Greens, which is really about, going back to basics and learning again about, the nature of how to interpret a significance test and what underpins that. We have a lot of online materials which are free to Smart Vision customers or are available for purchase. And we provide consultancy services. So we provide various levels of consultancy service, whether it be 1 or 2 days of consultancy time to support a project you're working on, or 3 to 5 days to investigate your data and give you some advice and a little series of recommendations, or a much more involved analytical deep dive where we explore your data landscape to test hypotheses, identify problem areas, and find key outcome drivers, or even develop new applications. In terms of working with us, you should bear in mind you can source your software online directly from us. You can buy SPSS directly from us. We also offer, as I say, training consultancy services, as well as identification and recruitment of analytical skills in your organization. We generally offer no strings attached technical and business advice relating to all things analytical to people who are either customers of ours or not. So you feel free just to reach out to us and ask us a question. We'll do our best to support you. We also offer our own formal technical support services around the SPSS product line. I do hope you found that useful. The next session we're going to be looking at is again returning to SPSS statistics, but looking at all of the different methods that we have for cleaning data. So if you're interested in that, feel free to register for it, and we look forward to seeing you soon again. Thanks very much.